Thank you, everybody. Agents, agents, agents. So many talks about agents. So I really appreciate you guys staying towards the end. Am I the last talk? No, there's one more, right? There's one more. Okay, you guys are towards the end, and we're going to have a little 10 minutes together. So I'm going to do like a quick Naruto speed run through these talks. And there's two takeaways. If you're gonna stand up and leave, there's 2 bullet points I want you guys to take away. Number 1, I want to share how we're thinking about approaching the agentic internet. And number 2, the summary here, is that we want to make sure that we're able to provide context for AI applications. Because without context, at the end of the day, it's basically a SaaS platform that you still have to get out of bed and operate. All right. I don't know how to use this. Okay, here we go. So when we think about why are we building the agentic internet, is that our biggest thesis is that there's going to be more AI agents than there are humans. So if we consider that as even just an addressable market, as a workforce, then what that means is that we are here to build an internet for the largest consumer that we're about to experience. And why this is even feasible is that over time, rapidly, these models or the context for AI has been achievable over time. When we think about how humans acquire education, right? You have to pay, in the US, a crap ton of money, go for 4 years, and gain a lot of information. With the rise of any kind of education, internet, books, libraries, et cetera, you are able to achieve that knowledge base as a human being even faster, even cheaper than ever before. I mean, remember when only, priests could read back in the day, right? So when we're looking at even the proliferation of these LLMs, the context that's needed for AI, why has it proliferated to even 2 million? So one of the biggest examples here is that the need for specialized contexts is extremely important. If you're dying from a cancer, you don't want to go to a general doctor, right? You're going to go to a specialized doctor in a specific field that can treat that type of information. So even if you are looking at ChatGPT as an example, it's incredible. You're able to get general information, but at the end of the day, you still have to go to a doctor. You talk to any PhD in their program, and they will tell you that ChatGPT is actually not helpful for them. It just doesn't have the breadth of information that is needed for something specialized and as the PhD field. So what we're looking at today is being able to bring these models smaller and smaller, smalls. I don't know, we're trying to make the internet cool. We're trying to be able to bring these models into smaller devices, and that's really gonna be the application layer that I'm gonna showcase today as to how we are able to own and build on top of the AI context. And with that said, the main focus of this slide is understanding the transition point from bots to agents. So I think what's most important here is actually looking at this workflow automation all the way to autonomous. As I said earlier in the panel, I used to work in robotic process automation. So what robotic process automation means is that you're able to automate the workflow for a lot of these enterprises, a lot of human interaction in the past. So we automated for Toyota, Santander, Western Union as an example. Agents is then this chasm between agents and autonomous agents. Sometimes people think of agents like bots because bots can be deterministic. They have a very specific if then that statement because they are built to help address something very specific. And once you go past that specific parameter, then the agent experience becomes really, really annoying. And then you're like, wow, I really wish I just could call a customer service person instead of talking to this, did I help you? Agent. And the autonomous aspect here of all of this here, the autonomous aspect is really about how do you create a application layer, an autonomous agent that has context and understand nuance so that it can make a decision based off of the highest probability that you want something to happen, right? So what you can see here is that that's the biggest difference between the bot and an autonomous agent. The biggest takeaway for this specific slide is understanding the depth of architectural complexity for an agent that can run autonomously, especially work streams. So one of the things that I want to point out here is with the proliferation of API calls, MCP, and being able to turn your trained model into a desired outcome, then you can start to see the difference between a bot that is supposed to fulfill maybe a customer service request or buy, sell on the exchange, to an autonomous agent that has context about you, which is, hey, trading bot, buy and sell this token for me. To an autonomous agent that says, hey, you are of this risk profile, you have this much disposable income, this is your dollar cost average that you can support based off of your income. I, as an autonomous agent, have a lot more context about you. So when we're looking at how we are building agents in DeFi right now, one of the biggest bets that we're building is that you don't have enough context. You go to any financial planner and you say, hey, can you trade this for me? Can you buy that for me? The financial planner is going to ask, what stage of life are you in? Do you have any dependents? It needs to have that type of context. So at the end of the day, what we're really trying to do is provide that living knowledge or that context for AI application. And one of the reasons why I keep saying the word context is I think that this narrative is often lost in the sea of agents, bots, DeFi trading, so on and so forth. Because at the end of the day, if we don't talk about context, we are just rebuilding the App Store all over again. You're gonna have to give context to that. I mean, that's why SaaS can still be so annoying. You still need to be certified to run the SaaS platform. Who is the project manager? Did you even update that ticket? Once that ticket is outdated, right? And so when I talk about context in the layman's terms, on the technical terms for those who are technical in the audience, this is what we talk about in terms of Gaia building out inferencing for AI applications so that you can have that potable context across different applications, across different stacks, so that your applications or your agents can learn about your intent over time. So this is a really big, really big architectural example. Take a picture. Basically, the question is, how does the token work in the economy? Why are we paying agents with tokens? TLDR, AI agent is code, fiat, not code, crypto, code. Pay agents with code. Okay. And the best analogy I like to use for this network design in layman terms is YouTube. So what you see here is that there is a lot of like, hey, there's domains, there's nodes, what does that actually mean? And on the application level, which is like the top bar, domains and nodes, is the analogy of YouTube. When you look at YouTube, it is a knowledge domain. It is a knowledge knowledge database, if you will. How do I plant a potato? How do I fix a bicycle? I'm going to go onto YouTube and I'm going to search for that knowledge domain. Then what you have is YouTube's version of verifiability. What you can see here is we talk about verifiability, right? And the YouTube verifiability is how many people liked it, how many people commented, and then how many people subscribed, right? So this is a type of kind of binary and not very nuanced type of verification. And so one of the things that we're doing is trying to build the whole stack of how do you provide true verifiability based off of intent. Then how do you stake, good Lord. How do you stake that type of verifiability? And then what is the application layer that you want to build on the shared context? So in the example of YouTube, that is a application layer that is essentially in Gaia, the domain. A YouTube channel can be thought of as a domain, and the videos in that YouTube channel, all the gardening videos, can be a cluster of nodes. And as we talk about bringing these types of models into smaller and smaller design, one of the announcements that we made at KBW last week was looking at being able to bring these models onto a device, onto edge computing. We remember 2015, Google Glass. It's extremely hard 10 years ago, maybe today, on bringing models locally onto a device like a Google Glass when the RIM is so slim. And so one of the biggest kicker for this example is how are you able to train your own AI over time completely offline? And how are you able to engage with your AI completely online, offline? And so this is one of the application proof points that we're trying to build towards the agentic internet, because we truly believe to reach an agentic internet, you need to understand how do you even retain information when you can't just Google that information. And so the main concept that we've been really focused on this year is really edge computing and bring AI to edge computing, specifically with our open source edge computing model. One of our chief scientists came from the Linux Foundation. He helped co-create Wasm Edge, which makes it possible for you to run these models on device, on smaller devices, and being able to coordinate on-chain, off-chain, online, and offline training as well. And what we truly believe is that for us, it's not a wall garden. We are completely open source. For you to be able to have truly an agentic internet and agentic economy, it really requires a lot of partners in the ecosystem. I think what we already see in the headlines is, let's say Meta trying to build a giant data center over here, other company trying to build a giant data center over here. They have the whole verticalization or stack to be able to ship their products to WhatsApp and Ray-Bans and all that stuff, right? And one of the reasons why we believe that this agentic internet needs to be decentralized is this need for distributed context, right? So this is why we build companies even outside of our own company. Meaning that's why you go to conferences, you meet other companies, what are you guys building, how are you guys approaching this topic? If you're just trapped in a room and you're just like learning through a book, you're not gonna extend that type of context. So I think this is really the intent here. And one of the proof points that we were able to really focus on last year is building out this context network that I just mentioned, right, in this networking analogy. We have about 700,000 nodes, and these nodes are the retainers, or if you want to call it kind of like the databases of the context that is needed, that needs to be ported over to other application layers. And this year specifically, we're really focused on indexing. So very similar to how YouTube index different videos. YouTube index different videos on hashtags. If you guys look under the hood, it's like cat video, hashtag cat video jumps on bed or something like that, right? And the future of how we're indexing context in AI isn't going to be self-reported hashtags. It's actually through learning. It's actually through learning what is the context in the specific video. And actually, this is really interesting because I'll say one more thing. Clapper? Does anyone know Clapper? No, Clapper. Okay, it's more popular in the US. They have 10 million daily active users. As we talked about the intent piece, traditional videos, again, it's self-reported indexing. What's the engagement rate from social media? Clapper, they process about 500,000 videos a day. They spend thousands of dollars being able to just process the videos. Clapper is one of our partners that have completely moved their models from processing through, let's say, a closed source, closed environment, let's say an OpenAI, to Gaia, so that we have the ability to provide index, inference, and enough on-prem space to train and process a lot of the video training for something like a YouTube, a Clapper, so on and so forth. And so I think really the last thing here is the way we're tackling the agentic internet is really based off of context, and then how do you build a human environment, may it be funding, accelerator programs, to be able to support a lot of the applications that are coming together to build the next generation of the internet. So really, my ask today is, before you go to bed, before you call that Uber, come and say hello. I would love to know what you guys are building. I'd love to support you guys. We are completely open source. And yeah, let's build the internet together.